All right, this is going to be number 23 on page 289. A frog in a hemispherical bowl is shown below, or in this case right here, floats in a fluid with a density of 1.35 times 10 to the third kilograms per meters cubed. If the bowl has a radius of 6 centimeters and negligible mass, what is the mass of the frog? All right, so this is a floating bowl with a frog in it. So we're going to draw, there's sort of my bowl. And here's the water. So the water's all the way up to the edge of this bowl. And then, of course, we got our little green friend in here. All right, he's in here. He's sitting in there. So one thing we need to do is draw a force diagram. And so it tells us that the bowl has negligible mass. So that's not real life, but in this case, since it's got negligible mass, basically the force downward is going to be the mass of the frog times g, right? But why is it floating? Well, it's floating because pushing upward on it is this buoyant force. That's the reason it's floating. So what does that mean about those two? What it means about those two, it means they're equal, right? It's floating. The downward force of gravity of the frog, the force of gravity, the weight of the frog is equal to the buoyant force. So the buoyant force basically will be equal to the mass of the frog times g. That's basically the idea. Now, how do we find buoyant force? That is a good question. And if you look in your book and look in the notes, you'll notice that buoyant force can be found different ways, but one way it can be found is the density of the fluid. Remember, that's rho for density of the fluid. That's not frog, that's fluid now. Let's put a FL for fluid. Times the volume of the fluid displaced times G equals buoyant force. Well, what's buoyant force equal? It equals the mass of the frog times G. All right, so do we know all these? Well, they give us this number here. This number here, they tell us, is 1.35 times 10 to the third kilograms per meters cubed. That's what that number is. Now, if it was in water, if the frog was in water, that would be 1,000, but the frog's not in water. It's in some unknown fluid with a density of 1.35 times 10 to the third, basically 1,350 times volume. How do I find the volume of the water displaced? Well, the volume of the water displaced is going to be equal to the volume of this hemispherical bowl. What that means, it means I need to find the volume of the bowl. All right, and so let's make a line here so nobody gets confused about that, and a line here. The volume of the bowl, the volume of a sphere, I should say, is 4/3 pi r cubed, but since this is a hemispherical, it's half of that, so we're going to divide by 2. Well, that's going to be 4/3 times pi times, we got to change 6 centimeter radius. We got to change 6 centimeters to meters. So 0.06 divided by 100 meters. And we're going to cube that number. And then we're going to divide the whole thing by 2. And that is going to give us the volume of the bowl, which is the volume of the water displaced. So when I do that, I'm going to say 4 divided by 3 in my calculator, then do second pi times 0.06 math 3 divided by 2 gives me 4.5. So the number we get here is going to go right there. And that's going to be 4.52 times 10 to the negative fourth meters cubed. All right. Now, I want to point something out here. And what I want to point out is that my G's divide out. My G's divide out. All right. So I don't need a G. I just need it equals. Let me go back to black. I just need equals mass of the frog. So if I multiply those two together, 1.35 times 10 to the third and multiply by 4.52 times 10 to the negative fourth, I get mass of the frog equal to 0.61. And we have three significant figures in here, it looks like. And so, let me look at my calculator. Yeah, 0.611 kilograms. That is the answer, and that's the answer found in the book. And that's how you do that problem. And so you need to be sure you know how to do a problem like that for the test, and we'll get some practice tomorrow in class.